In this video, our objective is we are going to multiply matrices together. We are going to start by reviewing how to find the size of a matrix. Remember, the size of a matrix is the rows by the columns. In this case, we have 3 rows and 3 columns. In this matrix, there are 3 rows by 2 columns. When we multiply 2 matrices together, if I were to use this as example A and this one as example B, when we multiply them together, in order for it to be possible to multiply, the columns of the first matrix must match the rows of the second matrix in order for it to be possible to multiply. And then our final product will be the dimensions of our rows of our first matrix and the columns of our second matrix. Let's take a look at some examples. In these examples, we want to know if it will be possible to multiply these matrices together, and if so, what will the size be of our new matrix? Remember, it's rows by columns. So our first matrix measures 2 by 1, and our second matrix measures 2 by 2. These two dimensions must match in order for it to be possible to multiply the matrices together, and they don't match, so this one is not possible. In our second example, remember we have rows by columns, that's a 1 by 2, and this matrix is a 2 by 2. In order for it to be possible to multiply the two together, those two dimensions must match. So yes, it is possible to multiply those two together, and the dimensions of our new matrix would be a 1 by 2. Taking a look at example 3, our first matrix measures 2 by 5, and our second matrix is 5 by 1. In order for it to be possible to multiply the two together, those dimensions must match. And they do, so yes, it's possible to multiply these two together, and our resulting matrix will have dimensions of 2 by 1. In our last example on this slide, a 4 by 1 and a 4 by 1. In order for you to be able to multiply, those two dimensions must match, so this one is not possible. Let's practice multiplying 2 matrices together. First, we need to see if it's possible. This matrix is a 2 by 2, and we're going to multiply it times a 2 by 2. So it is possible to multiply them together. When we multiply these 2 matrices together, here is the procedure. To find the element or entry that's in the upper left-hand corner, we are going to multiply the first row times the first column. We multiply the numbers together, 4 times negative 4, and we add the second product, 1 times 1. To get our upper right hand, we are going to multiply the first row times the second column. We're going to multiply 4 times negative 3, and to that we're going to add 1 times 2. To get our next entry in the lower left-hand corner, we're going to multiply the second row times the first column. So we will multiply 0 times negative 4, and to that we're going to add negative 2 times 1. To get our last entry, we're going to multiply the second row times the second column. So we're going to take 0 times negative 3, and to that we're going to add our negative 2 times 2. Let's finish finding our result. So we have negative 4 times 4, which is negative 16, plus 1, that gives us negative 15. In the upper right hand corner we have negative 12 plus 2, that gives me negative 10. In the lower left-hand corner, we have 0 times negative 2, which is negative 2. And our last entry will be 0 plus negative 4, which gives us negative 4. That is the product of A times B. Let's reverse. Let's this time find B times A. So our B matrix is negative 4, positive 1, negative 3, positive 2. And we want to multiply that times 4, 0, 1, negative 2, which is our A matrix. So I'm going to come down here and we're going to do our multiplication. So we're going to multiply our first row times our first column. So we have negative 4 times 4, and to that we're going to add the product of negative 3 times 0. Then we're going to multiply our first row times our second column. So we have negative 4 times 1, and to that we're going to add negative 3 times negative 2. Now we're going to take our second row and we're going to multiply it by the first column. So we have 1 times 4, and to that we're going to add 2 times 0. And then we're going to take our second row and we're going to multiply it times the second column. So we have 1 times 1, and to that we're going to add 2 times negative 2. We'll finish and find our final product. So we have negative 16 plus 0 would give us negative 16. In the upper right hand corner we have negative 4 and a positive 6, which gives us a final sum of 2. Then we have 4 plus 0, which gives us an entry of 4. Then we have 1 plus negative 4, which gives us an entry of negative 3. That's our final product. So the question I have at the bottom of the slide, is matrix multiplication commutative? Can I switch the order? Will I get the same answer, A times B, as B times A? And the answer is no. In our next example, we'll find out if it's possible to multiply these two together first, and if so, we will find the product. Remember that we are finding the dimensions, which is rows by columns. So we have 2 rows and 3 columns. And in matrix B, we have 3 rows and 2 columns. So our dimensions match, and it looks like our final product will be a 2 by 2 matrix. So let's start multiplying. What we are going to do is multiply the first row times the first column. And remember, we are multiplying each pair together and then adding them. So we have 4 times 1, negative 2 times negative 3, which is 6, and 3 times 0. So we have 4 plus 6, which gives us a final sum of 10. Now we're going to multiply the first row times the second column. So we will multiply each set of numbers and then add the products together. So we have 4 times 5, which is 20. Negative 2 times 2, which is negative 4. So we have 20 and negative 4, which is 16. And to that we're going to add the product of 3 times negative 4, which is negative 12. 16 and negative 12 will give us a final sum of 4. Now we're going to multiply the second row times the first column, multiplying each element together and then adding their products. So we have 0 times 1, which is 0. 1 times negative 3 is negative 3, and to that we add negative 1 times 0, which is 0. So our sum will be negative 3. Now we're going to add our second row times our second column and find that product. So we have 0 times 5 is 0. 1 times 2 is 2. and negative 1 times negative 4, which is positive 4. So we add the 2 and the 4 together to get our final answer of 6. Now I would like to multiply B times A. So my B matrix is 1, negative 3, and 0, 5, 2, and negative 4. And I'm going to multiply that times my A matrix. 4, 0, negative 2, 1, 3, and negative 1. But there are times when we only want to find certain elements. So the first thing we need to do is to see if it's possible to do this. So remember, we have rows by columns. So this is a 3 by 2, and this is a 2 by 3. So it is possible to multiply them together when we reverse the order, but our dimensions will change. This time we're going to have a 3 by 3 as our final product. So I'm going to draw the 3 by 3 matrix, putting blanks where our entries or elements are going to go. And there will be situations where you will only be asked to find certain parts of the matrix. So in this question it says find the element that is in row 2, column 3. So to find row 2, column 3, we're going to multiply row 2 times column 3, and that will give us our answer. So we're going to multiply negative 3, 2 times column 3. So negative 3 times 3 is negative 9, and to that we're going to add 2 times negative 1, which is negative 2. Negative 9 plus negative 2 gives me a final product of negative 11, and that will be row 2, column 3. Now we want to find row 3, column 1, which is right here. So we use row 3, and we multiply that times column 1. So here's row 3 and column 1. In our next example, we are going to be asked to solve for x and y. So we find that our x variable is located right here. If we multiply the second row of our first matrix times the first column of our second matrix, that will be equal to this product. So we're going to multiply those two together. Negative 2 times 9, and to that we add x times 2, and to that we add 1 times negative 1, and the result will be negative 13. Then I've set up a simple equation to solve. I have negative 18 plus 2x minus 1 is equal to negative 13. So I have negative 18 minus 1 gives me negative 19 plus 2x equals negative 13. So I'm going to add 19 to both sides. I have 2x then is equal to 6, and when I divide by 2, x then is equal to 3. Now if I'm going to solve for y, which is located right here in the upper left-hand corner, I want to multiply my first row times my first column, and that should give me y. So I have 4 times 9. To that I'm going to add 1 times 2 plus 3 times negative 1, and that should tell me what y is. So 4 times 9 is 36, plus 2 minus 3 should equal y. So I have 38 minus 3 should equal y. So my y is 35. Let's take a look at a word problem where we can use matrix multiplication to solve. Two lacrosse teams submit equipment lists to their sponsors. The women's team needs 5 sticks, 15 balls, and 16 uniforms, whereas the men's team needs 8 sticks, 22 balls, and 17 uniforms. Each stick costs $55, each ball costs $6, and each uniform costs $35. Use matrix multiplication to find the total cost of the equipment for each team. The first thing we're going to do is we're going to set up a matrix that has the equipment. So we can put these in the order of the women's team where we have 5 sticks, 15 balls, and 16 uniforms, and the men's team where we have 8 sticks, 22 balls, and 17 uniforms. Then we're going to create a matrix with the cost of each: 55, 6, and 35. Is it possible to multiply these two together to find the total cost of equipment for each team? Rows by columns. This measures a 2 by 3, and this measures 3 by 1. So it is possible to multiply them together, and our result will be a 2 by 1 matrix that gives us the prices for each team. What I'm going to do then is multiply the first row times the column. And when I multiply those together, I have 5 times 55, 15 times 6, and 16 times 35. So using your calculator, multiplying those 3 sets of numbers together and then adding them, we get an answer of 925. Then that would be the amount for the equipment for the women's team. Then I'm going to do the second row times the column to find the cost for the men's team. 8 times 55 plus 22 times 6 plus 17 times 35. That gives me a grand total of $1,167 for the men's team. So here we have the women's total, and here we have the men's total. Let's review. In order to multiply matrices, the columns in the first matrix must match the rows in the second matrix in order to multiply. Then the outer dimensions will give us our new dimensions of our matrix. Be sure to multiply corresponding entries in row and column, and then add them together to get the final product. Please remember to complete the reflection.